On the A320, there are two ventilation systems: lavatory and galley system and avionics system. The lavatory and galley system is fully automatic. Cabin air is passed through the lavatory and galley areas and is removed by an extraction fan. This fan pulls air into an extraction duct and then releases it overboard through the outflow valve. Note, the extraction fan runs continuously provided electrical power is available. There are no controls or indications associated with the lavatory and galley ventilation system. Now let's look at the avionics ventilation system. The avionics ventilation system provides cooling air for the avionics equipment. This equipment includes the avionics compartment, the flight deck instruments, and the circuit breaker panels. Let's now look at how the system works. Air is circulated by two fans, a blower and an extractor. These fans operate continuously as long as the aircraft electrical system is supplied. On the ground, provided that the skin temperature is above a specified value, air is taken from outside the aircraft via a skin air inlet valve. The air is blown through the avionics equipment, extracted, and then discharged overboard via an extract valve. This is the open circuit configuration. In case of very high outside air temperature, an optional avionics ground cooling unit can be installed. It ensures the cooling of the avionics ventilation air on the ground. The ground cool inlet valve opens when the aircraft is on ground, the engines are stopped, and the ground cool push-button switch is in auto position. The outside air is drawn by the ground cool fan through the inlet valve. The air from the cooling unit is then discharged overboard via the outlet valve. When skin temperature below a specified threshold and in flight or on the ground with thrust levers at takeoff power, both inlet and extract valves close. Air from within the aircraft is used. A skin heat exchanger is used to cool the circulated air. This is the closed circuit configuration. The skin air inlet valve is located on the left side of the aircraft and the extract valve on the right side. Both valves are inspected during the pre-flight walk-around for damage or obstruction. In warm ambient conditions, the system may go to an intermediate configuration. It happens when skin temperature is above a specified threshold and in flight or on the ground with thrust levers at takeoff power. In this situation, a small internal flap on the extract valve opens to exhaust some of the heated air overboard. A section of the ECAM cabin pressure page displays avionics ventilation system information. The vent, inlet, and extract indications provide information on the state of the inlet and extract systems. Normally, they remain white. The position of the inlet and extract valves can be seen. In the example shown, both valves are open. The avionics ventilation system is in open circuit configuration. In most cases, you will see this indication when the aircraft is on the ground. The ground cool indication gives the state of the avionics ground cooling system. Normally, it remains white. Here, with outside extreme hot air and engine stopped, both inlet and outlet valves are open. In this example, both valves are closed, and the avionics ventilation system is in closed circuit configuration. This is the normal in-flight configuration. When the small internal flap on the extract valve is open, the extract valve indication is in an intermediate position. This is the intermediate configuration. On the overhead panel, there is a ventilation panel that contains 3 push-button switches associated with the ventilation system. During the pre-flight cockpit scan, you should confirm that these switches are in their lights out position. The avionics ventilation system will then operate automatically and requires no further pilot input.